Welcome all. In this lecture, we will discuss about signal flow graph. So, signal flow graph is a graphical representation of a set of algebraic equations. So, in signals and systems, we are using signal flow graph in order to represent a system. So, in last lectures, we discussed how we can represent a system using block diagrams, and also how we can find the transfer function using block diagram reduction. So in this lecture we can discuss how we can convert block diagram into signal flow graph. So directly we can go to the steps. So consider this block diagram. So we have to construct this signal flow graph of this system, this block diagram. So signal flow graph consists of number of nodes, number of points and branches will be having gain values. So we have to first identify the nodes from this block diagram. How we can find the nodes from this block diagram? So there are number of possibilities for having nodes. So first input and output. So input point and output point will be a node. So this point will be a node. This point will be a node in signal flow graph. So this is input node and this is output node. Next possibility is summing point. All the summing points in the block diagram will be reflected as nodes in the signal flow graph. So this will be a node, this will be a node, this will be another node, and this will be another node. 4 summing points and 4 nodes. And another possibility is takeoff point. So all the takeoff points in the block diagram will be nodes in the signal flow graph. So this will be a takeoff point. So it will be a node in the signal flow graph. Another one is this one. Another one is this takeoff point, and another one is this takeoff point. And finally, there is one more possibility to having between blocks. So point between blocks, for example, like this will be node in the signal flow graph. So these two blocks, in between this block there is a point. So we have to also denote this as a node in the signal flow graph. So these are the nodes in this particular block diagram. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total 11 nodes in this particular block diagram. So first we can construct the nodes of signal flow graph. So 11 nodes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 nodes. So out of these, first one, this is input node R of S, and this is Y of S, output node. So this point, this the signal is input signal, and this is output signal, 11th node. So this is input node and this is output node. So input node will be this one, and output node will be this one. And again next we have to draw the branches and gains also. So first we can draw the branches will be in between these nodes, connection between these nodes. So we have to first draw the branch between 1 and 2. So 1 and 2 there is a simple interconnection only. There is no gain, only interconnection from input to the summing point. So there is a simple connection. The signal is flowing from this 1 to 2. So direction is this side. Okay, arrow mark should be from 1 to 2. And there is only one connection only from connection to this input node to the summing point. So there is no gain. So we can mark as 1 as gain, unity gain. From 2 to 3 also there is only a connection between these two summing points, no gain. So we can simply connect with the direction from 2 to 3, signal is flowing from 2 to 3, and gain will be 1. Next, from 3 to 4, this is 4 is this node and 3 is this node. There is a gain G1, and the flow is from 3 to 4, and there is a gain G1. So we have to mark the gain G1. Similarly, from 4 to 5, node 4 to node 5, the direction is 4 to 5, and there is a gain G2. So we have to mark the gain as G2. Similarly, 5 to 6 is only interconnection between a takeoff point and summing point. So just a directive mark, arrow mark 5 to 6, and 1 is the gain. 6 to 7 also only a interconnection. So only a branch gain 1, arrow mark is from 6 to 7. In between 7 and 8 there is a gain, and the flow is 7 to 8, so arrow mark is like this, and gain is G3. 8 to 9 it is only intersection between summing point and takeoff point, so direction and gain is unity. From in between 9 and 10 there is a gain, so 9 to 10, arrow mark is from 9 to 10, and gain is G5. And between 10 and 11 there is nothing, no gain, so only interconnection, so 1. And next we can mark the additional gains. So there is a gain from 7 to 8. Addition to G3 there is a gain G4 also. So from 7 to 8. So we have to mark like this, 7 to 8. This should be noted, the direction should be noted. It is from 7 to 8. Direction is like this. And the value is G4. Since this it is to plus, this is added, we have to mark G4, plus G4. If it is minus, we have to mark it as minus G4. Since it is plus G4. Similarly, the feedbacks. Feedbacks means to reverse direction. So firstly, H1, 5 to 3. It is from 5 to 3. H1 is from 5 to 3. So the arrow mark should be 5 to 3. The arrow mark is very important. Direction is very important. So 5 to 3. And the value of the feedback is H1, but it is minus, entering the minus terminal. So we should note that minus H1 should be minus H1. Gain should be minus H1. Similarly, H2 is from 9 to 2. 9 to 2. So the direction is like this, 9 to 2. And it is plus here, so plus H2. Minus here, so minus here. It is plus here, so plus here. Here also we have to consider the sign, plus or minus. And finally the H3. So H3 is from 10 to 5. Sorry, 10 to 6. It is from 10 to 6. So again the 10 to 6, so arrow mark is from 10 to 6, and the value is H3, gain is H3, but value is minus, sign is minus, so minus H3. So this is the signal flow graph corresponding to this block diagram. And application of signal flow graph is, so we in last lecture we discussed how we can find the transfer function from this block diagram by following block diagram reduction methods. So by this signal flow graph itself we can find transfer function by Mason's gain formula without any reduction or simplification. So that is the application of signal flow graph, which we can discuss in next lectures. So with this we can wind up the session. Thank you.